Good evening, students. Today we are starting with the seventh sum of exercise 3A. You can see here in seventh sum we have given that in an auditorium the number of rows is equal to the number of chairs in each row. If the capacity of the auditorium is 2025, find the number of chairs in each row. So we have to find the number of chairs in each row. We are assuming this equals to x. Now it is given that number of rows is equals to number of chairs in row. So it means number of rows becomes x. As we are assuming number of chairs equals in each row equals to x. Now in the question it is given that the total chairs is 2025, right? But we are assuming that number of chairs in a row is x and the number of rows are also x. So to find the total chairs we have to multiply them. It is x into x is equals to total chairs. Now this equals to this we can put because both are presenting the total chairs. So x into x is equals to 2025, or we can write x squared is equals to 2025. So there we get x is equals to under root 2025. Now find the factors of 2025. So we can find the factors of 2025 like this by prime factorization method. So all these are the factors as 3 into 3 into 3 into 3 into 5 into 5. From this we get 3 into 3 into 5, that is equals to 45. So we have to write like this, hence the number of chairs in each row is 45. Now the next one. In the next one we have to find the least square number which is exactly divisible by each of the numbers 8, 9, 10 and 15. So we have to find the least square number, right? So to find the least square number we have to first find the LCM of 8, 9, 10 and 15. Then we have to multiply this LCM by the alone numbers whose pair is not there, right? So how to proceed? Just find the LCM of given numbers. So here you can see the LCM of these numbers. The LCM of these numbers we get like 2 into 2 into 2 and 3 into 3 into 5. Here 2 and 5. They doesn't exist in pair. So we have to multiply by 2 and 5, that is by 10. So required least square number that we have to find. So to find this we have to multiply all these factors by 2 and 5. So the product of these numbers is 360 and 2 and 5 becomes 10. So multiplication is 3600. So the required least square number is 3600. So this is the last sum of exercise 3A. Now we are doing the properties of perfect square. So before starting the exercise 3B we are doing the properties of perfect square. So here you can see the first property, the square of even number is always an even number. You can understand this by example. We know that 2 is an even number. So you can see the square of 2, that is 2 square, also 4, that is also an even number. Now the second property is the square of an odd number is always an odd number. So you know that 3 is an odd number. Now square of 3, that is 3 square, it is 9, it is also an odd number. The third property is the square of a proper fraction is always a proper fraction. So just see that with the help of an example, we know 3 upon 5. This is a proper fraction as numerator is smaller than denominator. Now find the square. So the square of 3 upon 5 is 9 over 25. Here also you can see the numerator is smaller. So this is also a proper fraction. Now the fourth property is a number ending in 2, 3, 7 or 8. It means the ones place of any number. If the ones place of any number is 2, 3 or 7 or 8. If any of these number exists at one's place of any of the given number, this is that number is never a perfect square, right? Like 12, one's place in 12 is 2, so 12 is not a perfect square, right? Now the fifth property, it is given that a number ending in odd number of zeros is never a perfect square. So you can understand this property with the help of example. I am writing here 20. So here number of zeros is 1. So you know that 10 is not a perfect square, right? Now 1000. Here the number of zeros are 3. So know that it is not a perfect. Now taking the example of 100. There are 2 zeros, right? Even zeros. So it is a perfect square. That is the difference between the numbers that are perfect square and not the perfect squares. Now the sixth property, it is given that the sum of first odd natural numbers, sum of first n odd natural numbers is n square. So you can understand this with the help of this example. It is written that sum of first n odd natural numbers. Here I am taking first 4 odd natural numbers, 1, 3, 5 and 7, and here in right hand side I am writing 4 square because I am taking first 4 odd natural numbers. So here I have written 4 square as given in this property, right? Now 4 square is 16. Now check the sum of these numbers. 7 plus 5 12, 12 plus 3 15 and 1 16. That is the answer. So without adding these numbers we can simply get the sum. Now check the next example. It is given 1 plus 3 plus 5 plus 7 plus 9 plus 11. Here we have 6 numbers. So 6 square is 36. You can check by adding these numbers that this is right. Okay.